Okay, we are now on the last part of lesson 4, Introduction to Kinematics, Motion Graphs, and Motion in One Dimension. So for this last part, we're going to have to practice drawing motion graphs and converting them into one type of graph to another, specifically displacement versus time into velocity versus time graphs. Let's start with our first example here. We have here a motion graph of displacement versus time. So how are we going to know if it's displacement versus time? So you can see here you have x, so displacement, and this is t over time. And we're going to analyze this one. It's a straight line here, which means that it should have a constant velocity according to our discussion previously. And according to our previous discussion also, the slope of a displacement time graph means the rate of change of time of displacement over time, and that should also be velocity. Okay, so from here, let's see, that's displacement. So that's 7. Let's try to search for the v. That's 7 meters over 7 seconds here. Okay, 7 over 7, and that would give you 1 meters per second. So this should be the velocity that we're going to plot here. So this is now the velocity versus time graphs, and since we have here 1 meters per second as the velocity, which means we're going to plot from here to here. Now, should it be on different direction or should it be ragged? Let's see. Since from our time 0 up to time 7, as you can see, the velocity doesn't change, which means that from time 0 up to time 7, our velocity would not also change in our velocity time graph. So from here, out of all the choices, the answer would be letter A. Okay? So bakit hindi pwede yung letter B? So as you can see here, there's a change or there's an abrupt change of velocity here, but that's not shown in our displacement versus time graph. Letter C is also incorrect since the velocity is 0 meters per second and our velocity is 1 meters per second. Meanwhile, on letter D, as you can see here, there's a change in velocity, which means there's an acceleration. However, in our definition here, there's no change in velocity and there should not be an acceleration. Okay? So, anong graph kapag ganito ang nakikita natin? It should be like parabolic curve, something like this one. Okay, that's it for example number 1. Okay, so we are now on to our next example. So for this one, it's obvious that we have two situations. The first situation would be on this part, then the second situation would be this part. This would be situation 1 and this would be situation 2. In order for us to translate it into a velocity versus time graph, we need to find first what's the velocity. And as per our definition, velocity is equal to the rate of change in the x position or the displacement and the rate of change in time. So this would be the formula for searching for velocity 1 as well as searching for velocity 2. So let's find first the velocity 1. So that's the rate of change. A while ago we did not write it down since it's typically from 0 to 7 kanina. But this time we have two different scenarios, so it would be clearer if we write down it properly. Okay, so the rate of change means the final position minus the initial position. Okay, so which means delta x is also equal to xf minus xi, or final minus initial, as well as delta t. So what is the final position of the situation in velocity 1. So the final position is 3. So that's 3. And then initial position is 0. So you have 3 minus 0. And in terms of time, you started at 0 and then we ended up at 2. So that's 2 minus 0. You plug that in your calculator. You're going to have 1.5. So that will be 1.5 meters per second. Okay, so next situation, we have velocity 2. Still, same formula, delta x over delta t. And our delta x for situation number 2. So we started at 3, and then we still ended at 3. So that's 3 minus 3. In terms of time, we started at 2, we ended up 7. So that would be 7 minus 2. However, it wouldn't matter since 2 minus 3 is 0 divided by whatever the value here, 5. That will still give you 0 meters per second. Okay, so this is our velocities in the two situations. Let's now try to plug it in. So that's 1.5 meters per second, and that's about right here for about 2 seconds. So that's 1, 2, right it there. Then sudden drop or a jerk from 2 seconds to 7, you have 0 meters per second. Okay, so and that would be letter B. We are now on to example number 3. This time, we're now converting from velocity versus time into displacement versus time graph. Okay, let us just first recall that the slope of velocity versus time graph indicates v over t. So v over t, and v, or the change in v and the change over the change in time, means acceleration. Okay, and then the area in a velocity time graph means displacement. Okay, if an area such exists. Okay, so first, since this is a velocity time graph, it's obvious that our velocity is -1 meters per second. Okay, so if it's a -1 meters per second, okay, so again, if it's -1 meters per second, it means that since velocity is equal to displacement over time, it means that we have a rate of 7 over 7 as per our choices here. Okay, since all of our choices came from 0 to 7, 0 to 7, 0 to 7, 0 to 7 in terms of time. And the only thing that would result to a 1 or a -1 would be same number divided by itself. Okay, so now the concern would be between A and D, since B can't and C can't be the answer, since C has a change in velocity. That means my acceleration, but it's not shown here in our original graph. And B wouldn't be the answer because there's no change in its position in terms of this one. Wala naman siyang sinabing pumunta siya sa left or right. Okay, so between A and D, we now have two choice, and according to our lecture last time, a positive velocity means it should change from this one, from position 1 into position 2 ng paangat, right? Since it's positive velocity, meaning it's going to the right. since you have 0 to 7 meters. Meanwhile, a negative velocity means you came from 7 meters, but then you go to the 0 meters. Okay, meaning you are actually slowing down. Kasi from 7, napunta ka na lang ng 0, so bumabagal ka throughout the duration of time. Which means the correct answer would be from 7, papunta ka ng, from 7 meters, bumabagal ka. That's why you move through time. And as time passes, the distance you travel becomes lesser and lesser. So the answer is letter D. Okay, last example. We have 3 situations here. This is the first situation. This is the second situation. Let's put it 1, 2, and 3. Okay, so again, the area means displacement. The slope means acceleration. Okay, so for our first situation, as we can see here, we have a velocity of 0 meters per second. Meanwhile, on our second situation, it increases into 2 meters per second. So gumalaw. Meanwhile, on our situation 3, it goes back to 0 meters per second. Okay? So the only thing that has an area here is 2, right? And again, the formula, the area on a velocity versus time graph means displacement. Okay? So in order for us, for example, to search for x2, we need to find the area of this situation here. And the formula for the area of a square, since it's a square, is a squared. Okay? Which means x2 should be a squared, and the value for that is 2 squared. 2 squared would of course be 4. We are searching for position. The unit should be in meters. So this is now your position for situation number 2. So what if we try to translate it into a displacement versus time graph? Let's analyze first the situation 1. And situation 1, it shows that 0 meters per second, meaning until the 2 second, it has 0 meters per second, meaning hindi siya gumagalaw. So, if you're not moving, you'll stay at 0 meters within 2 seconds. And after a while, you increase your velocity, right? You increase your velocity here. So from 0 meters per second, this one, from 0 meters per second, pumunta siya ng 2 meters per second. Right? Pumunta siya ng 2 meters per second. So how far? And the answer would be this displacement that we have searched a while ago. So it should be 4 meters by 4 seconds. So this is now your answer. And then, after that, the velocity still goes to 0 meters per second, which means it suddenly stopped. Ibig sabihin nun, if it stopped, your position will also stop. Right? Something like that. Since, pagdating niya ng 4 meters, hindi na siya gumalaw. Okay, let me repeat. Una, started at 0 meters per second, hindi gumagalaw, and then it increased in velocity, which is 2 meters per second. Ngayon, gaano katagal yung ginawa niya? To find that, you need to search for the displacement. And according to our principle in our previous discussion, the area on a velocity versus time graph means displacement. And if we observe here, it's a square. It means a squared is equal to 2 squared. That will be 4m, which means within 2 seconds of this one, it moves onto 4 meters. So that would be 4m, something like this. After a while, huminto ulit siya, 0 meters per second. So it will stop at 4 meters. And then the answer would be letter A. And that's how you do it. That's how you convert distance versus time into velocity versus time and vice versa.